kind of going to do a lot of things today. I'm going to stretch your minds a little bit. We're going to look at a bunch of different technologies, so it's not just estimating. We're going to touch on estimating, but we're going to talk on how we can really maximize technology in a lot bigger scope. I've written a basic description of this class, and I won't read slides to you today. I promise I will PowerPoint you a lot, but I think we'll actually jump in here because we got a relatively small group, and I can jump into some of the applications and show you a couple things. But I did want to do kind of an aggregate survey with this group, just so you're somewhat interactive with me today. So can I just get a feel for the room? Are there any architects in the room? Any brave architects besides me? We got one, that's right. All right, so keep your hand up, Mike. All right, so how many engineers or contractors do I have in the room? All right, keep your hands up. How many estimators on top of that? All right, so the estimators, keep your hands up. Everybody else drop your hands. All right, so this is an awesome captive audience to have this many estimators. Thanks, guys and gals. In the scheme of the things that we're doing on a day-to-day basis, communication is like the most critical thing. And architects and engineers and estimators, we all communicate in similar ways, but not the same ways. And so I've had kind of a unique experience in my role. I'll tell you just a little bit about myself so you have some context, because I think context is one of the most important things in all technology. Besides communication, it's always understanding what is the task ahead of you, what's the project that you're going into, who are you going to work with, what's their experience. Having that context helps you to strategize how you're going to approach that project, right? A 6-month or a 6-week project or a 6-month project has different timelines, different constraints, and it has different pressure. Just like a $10 million job or a $110 million job, different pressure, different teams, different personalities. And the great thing about our industry is it's like the ultimate calculus equation. The variables constantly change every day, almost by the minute. Right? Job sites are constantly changing. They're a highly active place. The office is moving around. You're working with different teams. Even if you work with the same architect or the same mechanical contractor or the same electrical subcontractor, the people that you ultimately put those teams together with are always different. So you may have had a really great experience on one job, and then the next job you got a slightly different crew, and you got to reorganize those relationships and how they work and what those workflows look like, even though you're using the exact same tools. Does any of that ring true to you guys? Is that kind of? All right, so I'm going to kind of start off. So I mentioned a minute ago that I'm an architect as well. So you're probably wondering, what does an architect know about estimating? Nothing. I actually know just enough about estimating to be really, really dangerous. And so in my role, I came from the architectural side. I understood modeling really well, I understood process, I understood how a building went together. Not necessarily how to build it, but I understood in pretty good detail how it should go together, at least conceptually. I had a lot to learn, but over the last 15 or 20 years, I've learned a thing or two. But what I learned most was it always comes back to communication, whether it's on 2D drawings, a 3D model, an email, a set of specs, an RFI, an ASI, or whatever acronym we can come up with for a 2D sketch that comes across an email at 2 o'clock in the morning on a Saturday. Because we get information all the time. And on top of that, we have a ton of applications now. We have cloud-based tools, we have desktop tools. Does anybody in here have cloud-based tools? Anybody working with like BIM 360 or Assemble or Plan Grid or any tools like that? All right. So that's an interesting statistic. So out of this whole room, only 3 people raised their hand using cloud tools. Nobody else uses cloud tools. Can we try it one more time? Who uses cloud tools? Who uses the internet? Every day. Right? Who has a phone? Who has an iPhone? Right? Gimmicky stuff, right? Somebody's calling me. Gimmicky stuff. But it's interesting to me that there's only 3 or 4 people that raise their hand using cloud-based tools. In terms of how we communicate today, we are hosting all kinds of content in the cloud. Whether you know it or not, pictures of your kids on Facebook or LinkedIn, whether it's drawing files or model files, we use a ton of cloud-based computing. It's just not always really in your face. So I work for a company called Preconstruction, so I'm going to kind of spin through some of these slides here. We've been around since 1979, so I got to give you a little bit of the marketing spiel. So about 40 years old now. We were originally based in St. Louis, but we've grown across the country. We work in, I think, 39 or 40 of the states now, just where the work takes us. We recently added an office to Kansas City officially, so we have a brick and mortar downtown in Wyandotte. And so we've been in that office for a little over 2 years now. But we've been in the Kansas City market for over 15 years. So as a GC, we've kind of approached projects in a variety of ways, and we've grown through a lot of our relationship with subcontractors, architects, owners, facility managers, you name it. And so, there's a lot of statistics up here, but we didn't get there just by accident. So we were very strategic in the tools that we use and the way that we apply them on our projects. And so that's what we're going to kind of talk about today is how do we get the biggest bang for the buck out of the technology that we're investing in. And I want to make sure that I underline that word, investing in, because we don't own the software, right? Nobody owns the software except for the vendors out there. So we may have some proprietary things that we build in-house, but for the most part, we're all subject to Revit and Assemble or some other estimating platform, and we get the tools that they give us. We give them the feedback that we want new tools or new buttons or new workflows, but we're largely subject to what they can provide that kind of satisfies the masses. So at Parrot, we took a really direct approach to partnering with these different software vendors so we could have a real impact on the way that the tools were being developed, so we could finally get some of the features and functionality that we needed to serve our market, the way that we approach projects, the way that we build. So, kind of as we jump into here, I will kind of run through this real quickly here. So what we're going to do is kind of run across the tops of the waves a little bit here and just touch on a little bit of a lot of different technologies. And so is anybody in here using drones, for example, on your projects? Anybody? 1, 2, 3, 4, 5, 6. Okay, so half dozen of you are familiar with drones. There's laser scanners, there's augmented reality, and virtual reality, to name a few. Obviously, we're at an estimating conference, so you're all probably using some form of an estimating platform. Who's still using Excel to do an estimate? Come on. Yeah. We're not absent of that either. We use it for various things as well. So it's great to stake a claim and say that we use technology a certain way, but the reality is we still have to get work done. So we're going to invest in technology that we think is going to make our teams more efficient, that we're going to get more information, that we're going to get it in more real time. But at the end of the day, some things just got to get done, and you don't necessarily care how the sausage was made so long as at the end of the day you have sausage, right? So let's kind of dive into some of these benefits. So our approach to technology over the last 6-7 years now has been we're going to go 100% cloud. So we run all of our projects with cloud-based technology for the most part. We have a few desktop applications that we still use, but what we were striving for was by hosting things in the cloud, we would have this concept of a single source of truth. And I know that gets beat up a lot in the industry, but it means a lot to us because we have siloed data like any other company, and we're trying to mitigate that as much as possible. The more silos we have, the less continuity we have in the way that we communicate, and the more latency rather that we have in what we're getting to our different team members. We're in that early pre-construction phase. We get a set of drawings. We start to do quantification on it. We start to schedule from those drawings and try to put together a game plan on how we're going to run a project. If we don't get the next set of drawings back up to the team as that next DD set comes out or what have you, then we're losing our competitive advantage in going after that work. So we go after contracts that are of every type. You have CM, CM at risk, design build, design assist, design kind of assist, however you want to name it. But all that largely ties together to the way that we're communicating. And so there's a quote that I had picked up a few years ago, and I absolutely love it. Is anybody familiar with Phil Bernstein, the architect? So Phil Bernstein came up with this quote in an article a couple years ago, and it was, architects create drawings and dare contractors to build from them. And kind of a neat thought.
I'd say it again then. Sorry.
Architects create drawings and dare contractors to build from them. As an architect, I giggle at that. But that's never our intent, right? We're trying to communicate in drawings or model format to explain the design intent, the scope of the work. But at the end of the day, we are not creating shop drawings. We're creating design intent drawings or contract documents. And we're trying to hold everyone to a higher standard, but at the same time, there's only so much you can put on a piece of paper, right? And it takes a lot of paper sometimes to communicate everything that goes in the building. So again, back to our strategy was, how can we communicate better? How can we remove the latency? How can we have the single source of truth? How can we leverage our teams more in a real-time type of format? You know, and some of the benefits of using BDC and BIM and all these other types of tools is that the more you communicate, the more confidence your project teams have. Prefab is all the rage right now, and for a good reason. You know, it's been in the shipbuilding industry, it's been in the car building industry for decades, but it's really been in the construction industry for decades. It just hasn't hit the mainstream of commercial is as widespread as you would expect. So, coming back to the ability to communicate, if we can give our project teams the confidence to BIM coordination, real-time estimating, making updates faster, we have more confidence that if we go to prefab something, that we are going to get the result of that work that we really are striving for. On the other hand, if your strategy is to go after prefab and you don't really apply a strategy that is going to be substantiated by the whole team, you're going to miss critical steps. And something that might be prefab and shows up to your job site isn't really worth anything, because you still end up modifying it in the field. And we don't want to do that. So, we do all kinds of projects. We do, red iron steel type projects, and then we do stick built projects that are, prefabricated or stick built based on the market. And so understanding what's going to fit that market or that region and that project type, budget and all the other constraints, really has an impact on the way that that strategy is ultimately going to work out. So, the rest of the bullet points are pretty obvious. We want to mitigate our risk, right? We're trying to eliminate paperwork. We're already busy. We're running, multiple projects at a time. So we don't want to inundate architects or anyone else with RFIs, because if we have to write them, then they have to respond to them. And so what can we do to mitigate that risk? Again, communicating, building confidence, leveraging the tools that we have available to us. And this is where, it comes back to leveraging cloud-based tools has really been a big game changer for us. So, let's talk a little bit about context. So, I mentioned earlier that I think context is one of the most critical things in design and in construction. So, we use a variety of different types of tools so that we can have context. We use email, we use our BIM 360 platform, we use our estimating platform, we use our scheduling tools. We also use drones and laser scanners and robotic photo stations. And I can tell you that these things are all great by themselves, but they work amazingly better when you put them together as one unified tool system. Okay? And so the concept that I'm going to start to illustrate for us over the next, what we got here, about another hour, is how do we have a unified ecosystem that all works together, right? No longer files that sit, in different silos and you grab them and use the pieces that you want when you want to serve them up, but you have access to all of them all the time so that the right person has that information when they need it, okay? So if I am the project engineer or the project manager, whenever I look at, say, a drone scan or a laser scan, I see one thing that is entirely different than what the owner sees. I'll show you one of our simulations that we put together here is around just logistics on a site. If I'm the project owner, when I look at a simulation of how you're going to build my new facility on my active campus, and I see you putting construction fences up around my site, I'm like, wow, you're eating up all my parking. I'm going to have circulation issues for people walking around. What I'm communicating with them in those logistics studies is totally different than what the project manager sees. He sees opportunity for laydown areas and for how we're going to put the parking or the job trailer on the job site, and how we're going to do emergency egress, and where's the crane route going to go. Totally different visions, same set of data, right? But for me to get that same set of data in the past was always, well, I'm going to email it here, I'm going to host it over there, we're going to have a paper copy in the trailer. God help us. We can only move past paper. All right. So the concept here, though, is that if we can start to integrate these together, you have to have some rules and some strategy. So the strategy that we used was, okay, what is the one thing, what's the foundational element that holds all the glue of this contextual information together? Anybody know? What's the one thing that holds it all together? Okay, any civil engineers in the room? None? All right, so let's start with the basics here. So I was teaching my son's fourth and fifth grade class yesterday about how to use drones for construction and design. And I said, where is X, Y, and Z? Right? You guys all know this, learned this in elementary school, right? X, Y, and Z. If you know where X, Y, and Z is in this world, you have a coordinate system. And no matter where that coordinate system is, whether you made it up or not, it's the reference point, it's the foundation for your entire project. So we know where X, Y, and Z is on a project. Hopefully we know where it is in the real world. So what we do is we'll go out to a project before we've ever won the job, before there's even a contract in the peripheral vision. And we'll go survey the job site on our own. We own control on all of our jobs. Because we want to know where that project is in the real world so we understand the context of that project. Then we'll laser scan it if it's if it's an interior piece or it's areas of the building that you can't see very well. And if I'm an estimator, that's more information, more photos, more pictures of the back end of an operating facility. Drones give us all kinds of insight. They allow us to understand topography, the rooftops of buildings that we can't easily get to, how we're going to traverse a job site that's maybe wooded or where we may have to cut crane paths, things like that. It's amazing. Oftentimes we work on a facility that's in the middle of a semi-wooded area, and you're trying to figure out how are you going to mitigate the amount of trees you have to affect for the project itself, for the intended project itself. So, we have a lot of these different types of tools here. There's some basic rules around these tools, though. So if you don't know much about this, and I'm going to give you the 30-second version of this, there's some basic constraints around these technologies. Robotic tool stations, guys here on the bottom, have to have line of sight to work. They only work if they can see where they're pointing to, just like a camera does. They can also be connected to a GPS or a coordinate system that is across the state or across the country. Okay. The same thing for the drones. They're also line of sight. They primarily run off GPS, which comes primarily from satellites. And so their line of sight, they don't really like to fly inside of buildings. And even if they can fly inside buildings, they like to run into things, which is never a good thing for the drone or for the building. And then there's laser scanners. So the big difference between laser scanners and drones is that laser scanners can pretty much go anywhere you can go as a person, and they can collect data. As long as you know where you came from and you know where you want to go, you can scan your way into a building and scan your way back out. That's important because ultimately we're going to create kind of a quilt, and we're going to stitch all that information together. So if I'm an estimator and I want to understand, walking in the front end of a school or a conference center or something like that, as I walked in, what was the information that I did on that job tour that there's no way I'm going to remember? I certainly didn't have a tape measure that day, but I want to capture some of that information without having to make another trip back. So again, simple concept, but the idea of laser scanners is that it's saving you time. So to make all that work, let's check ahead here a little bit. So there's several different types of control on a project. You have your basic control of in the world, where are you? And that typically comes from our surveyors. We have our site control, which are the yellow dots, which is the control that we start to set up for our projects so we can reference this information. And then we have some additional line of sight type control that we put on adjacent buildings or structures so that we can progress up a building as we get into the construction phase, or if it's an existing facility, we need reference points for historic renovation type project. And then finally, as we're pulling this entire network together, we're ultimately tying this back to the system. So you're probably wondering, why am I telling you about drones? Why does it matter to me if I'm an estimator? Yeah, I get pretty pictures. Yeah, I can probably measure some of that. What's more important, though, is that if you're going to go into this project, we want to go 100%. If we're going to go after a job and we're going to really put our energy into it, we want to know everything about that job. And if we're going to put the energy into knowing the job up front, we want to leverage that throughout the entire project. We're going to assume we're going to win, and when we take off, we're going to go at 100 miles an hour, right? Even though projects start and stop and start and stop. The assumption is that we're going to put this control in place so we can represent throughout the rest of the project. This creates a baseline. So if this is imagine this is a great big field, and we have a lot of earthwork to do. Now I have my baseline. If I want to do cut and fill analysis from my civil engineer or from my architect who gives me a conceptual topography file that I can work with, at least I have something to work with. And it can be extremely conceptual, not even LOD 100 or like LOD 50, but at least I have something to kind of start with. But it gives me a baseline, and then as we go through the construction process, now I have something I can always go back to and compare and see how we're tracking on the project. At the end of the project, I can always look, now I can look back and say, where do we land and where do we start? And what kind of happened in the middle? That's information that we can actually do something with. Otherwise, it's just data, and there's no need to just collect more data. We have piles of data. So, drones and pre-con. So, show you some examples of this here in a second. Actually, I'm going to let this video run. So, what you're seeing here, so they're referencing the cloud. We host all of our content in 360. I promise I'm not pitching 360, but if you're not familiar with it, it's a fantastic platform. We use it on all of our projects. But this is a product that's a drone fleet management, flying, analysis type tool, upside scan. And so what we did with this tool is we're able to bring in data from our cloud repository for drawings and models and overlay it with the scan data that we get. This gives our project teams, not only the understanding of where, what the drawing intent is, but what it actually means in the context of the scan data. And so what you're seeing here, kind of highlighted really quickly here is, this is a drawing we overlaid on there, and we're measuring deviations from what our scan data said and what the drawing indicated. And because it's all integrated together, we can submit an issue, which ultimately will become an RFI, in this particular instance, back to the project team without ever sending an email. No email. Email bad. Right? So this lands into an issue management tool, and now it's actionable data. It's not in a silo. It's in an actual issue management tool that's assigned to someone so that they can respond to it. And if it needs to become an RFI, we can go to that next step. We'll come back to that here in just a second. I promise I'm not going to give you the entire history on drones. But drones are not new. What's new about drones is that you don't actually fly them. Doesn't make any sense, right? But I'm a licensed pilot. I fly drones. I know how to fly them with remote control. But we don't fly drones. We plan missions, and drones fly themselves. They use AI. So what we do is we say, look, I want you to fly this area of the site every Wednesday at 3 o'clock. Right? So somebody at 3 o'clock has to go out there and make sure the drone's out there, make sure it's set up correctly. They have to watch it while it flies. But they don't actually fly it. They set it up, click go, and they stand there and watch it. Right? Anybody can do this. It is not hard. What's hard is passing the licensing or the certification exam. Because I don't know about you guys, but reading nautical maps is not the easiest thing. Or aerial maps, sorry. So getting past the flight maps and understanding the different tickets and things like that, that's where the real challenge is. But drones are now being used in all kinds of industries. We use them on all types of construction projects. We help architects when they're on various types of design journeys that we can get involved with early. We work with civil engineers and we fly for them. We invested heavily in drones 4 or 5 years ago so that we could start to leverage this technology. But it's everything from mining and highway infrastructure. But if you think more about the construction-centric focus of at least where we're at is it's architecture, it's engineering, and it's marketing. Marketing. Is anybody in sales in this room? You're all in sales. Everybody raise your hand. Come on. We're all in sales, right? Because if you can't sell this technology to your leadership, you're never going to get it. You're never going to get the benefit of it. So hopefully, one of the objectives I have for being here and presenting this to you is that you see some benefit in this that you can sell to your management. Because these are the tools that are going to enable you to be more competitive in the future. So what can you do with drones? So obviously, it impacts how you plan your logistics. We talked about that a second ago. It impacts your design. It allows you to market your services, your progress, the way that you're going from day to day on whether it's steel erection, earthwork, just knowing how many cars were parked on the job site, knowing before you just started design how many cars are actually parked in the parking lot so you can go back to the city and ask for that variance. There's all kinds of use cases. Most of which, though, resolve back around how we get that information into a document or piece of information that we can cut elevations to it, measure, quantify, do volumetrics, whatever it is you need to know, depending on your role, so you get something out of it. There are, of course, some asterisk things you need to know about drones. You have to be certified. You have to have insurance because you're doing it commercially. You need to understand airspace and where you can and cannot fly, or when you can and cannot fly. There's some various things around that, but once you get past that, drones all basically do the same thing. They take off from the sky, they point a camera at the ground, it's line of sight, and they collect data. So once they do that, you're going to process it, and you're going to get at least a couple of different things that you can work with. Starting with, let's move on here to the next slide. So, let me back up. So I mentioned a minute ago that you don't actually fly. So who knows how to mow grass? Everybody knows how to mow grass, right? So when you mow grass, does anybody mow the grass like this? No. It's all in straight rows, right? Perfect straight rows this way. Sometimes, if you're like me, then you go back the other way, the opposite direction. Or not the opposite direction, but 90 degrees. So, same thing with drones. So you set up a mission, as I was describing earlier, and you tell it where you want it to fly, and it will come up with its own mission. And that's where it'll fly. So these green lines that are on here represent which way it flies and where the camera's pointing. So if you're doing a straight topographic survey and you just want to know the grades of the ground, it will put the camera straight down on the ground and take pictures every so often. And it does it on a very planned approach. So all these little dots over here, that's everywhere it took a picture. Right? So if you're doing this, that's reference to a nadir scan, which is straight down. Okay? If you want to know more about the face of a building, then you'll do what we call a crosshatch scan, but it's not oblique anymore. So it's depending on what you're trying to scan, it will look up at the building. And so in a crosshatch scan, you'll go in both directions and you'll tilt that camera up 15 degrees, 30 degrees, just enough so that it catches a little glimpse of the side of the building. So that when we try to stitch this stuff together, we get more of the three-dimensional aspects of the building itself, if assuming there's a building. And that's when the decision comes. So, over here, right, or my left, it's early, my left, your right, this is a heat map. And so, this is not the temperature of the Earth. This is a really quick way to interpret the data that we're getting out of these pictures. So, in this particular image, what's red is high, and what's blue or getting past purple into navy blue almost, or royal blue, whatever we want to call that today, that's low. Okay? So if I'm an estimator, I don't need to pull out a topographic survey or an Alta survey, which is mildly right. I can look at this thing really quick and go, that's high, that's low, this is where my fill's going to go, this is where my cut's going to go. Right? I don't have to be a rocket scientist to read this. I just need to know the basic rules of this key. We go week to week, and we can compare a scan and see how much earthwork has progressed on the job site. So now we can know, did they move 50 cubic yards or 5,000 cubic yards, or what kind of stuff that we actually have happened. But as an estimator, I just want to know, based on my conceptual design, where did I land? Or where am I landing at? So anybody familiar with like AgTech? Anybody use AgTech software? So similar to AgTech, except this is a spin focused on using drone technology. Okay? So it allows you to overlay all this information at the same time. So you can put contours on here, or it will create contours for you. You can overlay your drawing. You can get a quick heat map and get a sense of the site, what's going on that job site. This is obviously an in-progress construction photo. So we were looking at not only what's going on with the building, but how are we going to start to do final grading for the parking lots and that kind of thing. So it just gives us a feel, a sense, kind of an insight as to what's going on. As you get farther down the road, now you get you got a tool here that allows you to show progress. So going back to marketing, right? Depending on how your project's financed or how curious your owner happens to be, you can give them a daily, weekly, monthly video that shows them this is what happened last week. This is what happened over the last 3 weeks. Time-lapse or videos like this are awesome. And they tell a story. if it snowed, if it rained, you know, why did you have a stop work scenario? Well, I can show you exactly what happened. You know? So we mix this not only with drones, we also use job site cameras and do the same thing. But it's, again, it's getting back to communicating. So another way to do this is to build a full logistics simulation. All right, so this is a mix of laser scanning, drones, Revit, SketchUp, probably a handful of other tools that we mix together so that we can understand this job site now. Whether I'm the project executive, the owner, the estimator, the architect, we're all seeing different things, as I mentioned earlier. So this job is an active campus. We knew we were going to have to take down some buildings. We were adding new buildings. This is a senior living facility, so we knew that we had to be very careful about where deliveries came in and out. We didn't want to disturb people that were living there because this is a 4 or 5 year project cycle. So we want to make sure that we had a minimal impact on this owner and their tenants throughout the entire duration of construction. So we started this planning very early, went out, laser scanned it, flew the drone, modeled as much stuff as we could. This isn't even the final designs. A lot of this is still in progress. But to start to get a sense of what it was going to feel like. And in fact, this ultimately changed significantly from this image because when they saw this, they saw things they didn't realize before, right? So if I'm an estimator and I got to do a conceptual estimate, I want to get a conceptual estimate that's close but quick. How can we get there as quick as possible? So this allowed us to quantify the topography on this job site. Looking at it, doesn't seem like there's a lot going on there, but it drops 90 feet from one end of the site to the other. It's about 50 acres, right? It's in a northern state where they get frost and freezes the ground, which is good and bad. Depends on what we're building at the time. But this helped us understand a lot of this information, so we could really quickly throw together an estimate around what we're going to do on winter heat, what we're going to do on tinting and those kind of things, what we're going to do with concrete, when we could actually get concrete, we had to understand the local market and that kind of stuff. I mean, there's just a ton of stuff that goes into this. So I obviously can't give you every example, but I'm trying to paint a picture. You know, this was just something that we did over the course of about a week or two. And the amount of information they provided was really valuable. And it's a $200 million project, right? So, you know, will we do it on a $10 million job? Probably. We do it. So, kind of on another phase here. So, who does historic preservation, renovation work? Anybody get involved in big projects that are historic renovations? So, St. Louis, for the longest time, had a glut of historic buildings that had been shuttered for years, were in a state of disrepair. But over the last 10 or 15 years, the market's really started to bounce back, and a lot of those buildings are seeing another life. Well, there's a lot going on in these buildings, so I'm going to stop this thing and I'm going to go back so I can explain what's going on here. When you go into estimating things, or just trying to plan work or trying to design work, you, again, need to understand the environment that you're building in. Whether it's a building or a greenfield site or a brownfield site, you want to know what's going on under the ground, above the ground, next to you, who's my neighbors, what job or what roads am I going to be using, can I carry heavy concrete beams down the middle of this road, or am I going to get problems with that? All these different things go into how I'm actually going to plan a job, how I'm going to bid the job, how I'm going to schedule the job, right? So we get into these historic projects. New construction is fairly easy when you consider the variables that you have to work with there. But when you're in historic, it's a whole other thing because this exists. You got to figure out how you're going to fit everything you want in that box, right? And on a historic building, I don't know if you guys run into this, but not every floor is the same. The columns kind of meander a little. The structural grids kind of meander a little. Stairs aren't exactly the same. So what you're seeing here is everything that's red was a scan that we did, and everything that was black represented the model that we had from the architect at the time. To their credit, they did a really good job with what they knew, right? But to model a 17-story building and think you're going to get it right is, it's naive, I would say. So what we did was we went out and laser scanned it, and we figured out where are all the columns, where are all the actual walls. This is an L-shaped building. Believe it or not, it wasn't a perfect L, it was off about 1.5 degrees. So there was a lot of rework we had to do with the model. And so this is where communication becomes critical. I'll come back to this here in a second, but this is a fun story. So the communication piece is not just sending notes or picking up the phone, which, by the way, using the phone is still our number one way to communicate, because you actually get information really quickly and you don't have to interpret what an email says. But by using the models and working together, we're able to really dive into what is going on with the project. So when we dug into this model, I'm going to go back for a second, we dug into this model and we realized that the floor-to-floor heights weren't exactly right. They were close, but they weren't right. The columns weren't exactly in the right place. They were kind of close. The beam depths weren't right. The particular building I'm referencing, the last slide was a waffle slab. The waffles weren't the same. So we went to start repositioning this building and putting in new demising walls and new wet walls and things like that. In some places, we were right in the middle. We were clear we were going to hit a tendon. Other places, not so much. Historic renovation projects, oftentimes you have to maintain historic corridors and things like that, not effective. So when we dug into this and realized how far we were going to have to go, the scans became critical to the success of that project. And so, no different than this example here. All these magenta lines represent post-tension slab cables. Everybody have you ever done a repositioning on a PT slab? It's a great time. So what we did was we went out, started to do a little demo, started to understand where things were, the repositioning of this project. Everywhere that we wanted to put penetration in the slab was perfectly on top of the PT cable. And the way that we knew that was we x-rayed the entire slab. So this took us a little time. We were new to x-ray, but we x-rayed every floor of this building, every square foot of the building we had to scan, so we knew where the PT cables were. Because every floor was different. Even if you strand it perfectly, when you pour the concrete, they move. And this building was from the 60s, so they were 50 years old. Concrete was, well cured. And we ultimately had to cut 2 cables at the completion of this project in total. 2 cables. And I guarantee you, that everybody was a little nervous that day. All right, so let's get back to estimating here. So believe it or not, I had 60 slides. We're at 24. I promise I'm not PowerPointing you to death, but we're going to go through the rest of these in a hurry. So obviously BIM coordination is critical to what we're doing, back to communication. So what we try to do is we want to avoid doing clash detection until as far down the road as we can. We're really into clash avoidance for active design, right? If we know more about what's going on in the building, then we can design around it. So using scans or active models and pulling everybody onto the cloud, we can have them all actively designing in an environment where they know what's there and they can throw darts at the actual wall and not have to imagine where that wall is, okay? If you're doing prefab on a project that's a stick-built type of product, wood stud, metal stud, something like that, thousands of little columns, right? You're trying to coordinate where all these standpipes are going to go, where all your conduits are going to be, things like that. If they're not modeled, you can't do that very effectively. If you're not doing that very effectively, what's that do to your estimate, right? Because if we design it wrong, and then it has to be redesigned again, then guess who's going to have to update the estimate? You guys. Because I don't estimate, right? I rely on people who actually know how to estimate really well. But if our design changes and now we have to modify the floor-to-floor height, or our spans, or where our demising walls are going to be, or what type of spacing we have on studs, we go from 16 to 24 inch, or something like that. And that is stuff that takes a lot of time to crunch back through. Let's not do that. Let's do design coordination up front. Let's get the entire team involved. Not just the architect, not just the VPs. We need our structural fabricators involved. If it's a stick-built product like this, you need to have them up front, because they're the ones that are modeling all these little columns. So just kind of get a temperature. Does that make sense to you guys? Is that anybody else experienced with dealing with prefab and running into problems like that? Yeah. So it's becoming more commonplace as more and more projects are becoming either prefabricated or modular or some variation thereof. So what you're seeing on the screen here, I know the setup already played, is this is cloud-based clash detection, right? So we're really trying to do clash avoidance, but we work together as a team. And so this gets updated on a daily, hourly basis by the project teams. We typically meet for about an hour every week and go through design problems that as a contractor we need to help work through. But we don't sit in a dark conference room for 4 hours or 8 hours a day, co-locate, do all those fancy things. Because people want to work where they work with their other experts that they can bounce their questions off of. They don't need to be sitting in our office necessarily or in the job trailer. We want them to be where they're going to be most effective, and we realize that they're working on probably more than one project. So using this cloud-based approach, again, this isn't new technology, this has been around for a while now, but this has an impact on not only how we build, but also how we estimate and schedule. All right, AR and VR. Does anybody know the difference between augmented reality and virtual reality? Anybody? Any brave soul? Anybody? All right, come on.
AR augments existing reality. Virtual is different reality altogether.
Right. So when you're in virtual reality, you're completely consumed into an alternate universe, right? So you put these goggles on, you look funny, and you're staring at a screen that's really, really close to your face that your parents told you never to ever do, and now we're making you do it, right? It's kind of crazy. But it's great if you're trying to give someone an impression of what the world might look like, or how to fill it, or work with a design problem. AR is where you're augmenting reality, and you're superimposing a model or a vision on top of the real world. So in augmented reality, you put on a clear visor, more or less, and it's projecting what that's supposed to look like in the context of this room, for example. So where we're seeing a lot of benefit of this, and this is a single slide guy here, is we can start to get this out to different people. So about a year ago, the Oculus Go came out, which is the one that the young lady's wearing at the top there. It's wireless. So for the longest time, the barrier to entry with a lot of these technologies was you had to be tethered to your desk, which doesn't work on a construction site or a job trailer. It certainly doesn't work with a lot of the computers that the average person is using because they just don't have the horsepower. But as a VDC group, we're able to put together technologies, kind of post a PDF version of a visualization and hand it off in an Oculus Go. And so now you can visualize what that's going to look like. Again, coming back to Estimator. There's no reason that Estimator should be left out of this. So if we want to visualize what it's going to look like when we walk into a unit, if I'm the architect, we work with a lot of different architects and they use variations of this technology. The more clearly I can communicate to you what I want or what I'm envisioning for this hotel room, the better I can estimate it. If I'm the owner, the better I can give you the thumbs up or the thumbs down, so I'm not wasting the estimator's time or the pre-construction manager's time going back through and making changes and changing carpet, changing countertops, and changing hardware. Let's do it once, let's do it really well, get everybody to sign off on it, and then let's go like crazy, right? This is an extremely, extremely powerful tool, and it's just barely touched this industry, but it is absolutely awesome. All right, so we're going to breeze through this guy here. So construction management, obviously, in any project we need controls. So we talked about a little bit of controls around surveying, but issue management, document management, model management, all that comes into play. But as a builder, you would think, a lot of people think that that's just for the office. Not for us. We want everybody who has a phone or an iPad, which is everybody in our staff, to have access to this information no matter where they go. So if they're on the job site, they go to lunch, they go home, they're working on a Saturday from home, whatever they happen to be doing. If a question pops up in the middle of the night, I don't know about you guys, but I often will wake up in the middle of the night and go, what if? I think I may have forgot something, or did I remember to fix this column, or whatever it was. I can jump up at 4, 5, 6 o'clock in the morning and turn on my computer, and no matter where I'm at, I have access to the entire set of data, all of it. All the models, all the specs, all the drawings, everything. That is game-changing. When you walk on a job site and you don't have to carry drawings and a camera and all these other things, and a spec book, but the old adage that spec books sit in the trailer so they don't get cold, right? Like, what if you actually had the spec book with you when you walk on the job site? You can actually read it. Do I have the right material, whatever it is? It's phenomenal having information at your fingertips, and we're getting spoiled by it almost. I think Mike mentioned earlier that with estimating, with products like Assemble, you have to actually know what it quantified to make sure that it's the right quantity. When a model spits out a quantity for gross area or actual area, there's a huge difference there. But if I'm a self-performed contractor, I look at that differently. It's not necessarily just a waste factor. It may be the way that I buy drywall. Am I going to buy stretchers, or am I just going to buy 4x8s? You know, what am I using? And so, what about forms? You know, if I estimate just based on quantity, I'm going to give it, you know, a quick little formula and say, all right, I'm going to use this many forms across this entire project. But I'm not going to pour 1 million square feet in one day. So I can reuse those forms. So do I modify my formula, or do I modify the model? Right? There's all different ways to go after this. So the way that you set up that estimating database is going to be largely based on how well your team can work together and how well you can strategize on how to model and how to do the takeoff. All right, so we're kind of evolving here around data. So there's a big difference between data and actual actionable information. So I can have all the ones and zeros, I can do all the checklists in the world, I can do all the surveying, I can do all the point clouds I want, but if it's not actionable data, it's just taking up space on a hard drive somewhere, probably in the cloud at AWS is my guess. So what we're trying to do today, not trying, this is something that we've been actively working on, but it's getting better every day, I should say, is now we're leveraging cross-project reporting on jobs. So if I'm an estimator, I want to get better at estimating. Market gets tougher, you know, we're all busy, taking on more work, we're going to different places, different regions, different markets, union, non-union, all those kinds of fun things that we have to work through in our estimating approach, or our strategy for winning the job. So the more we know about the way that our jobs perform, the better we can inform our estimating process. So this is a dashboard from our 360 suite where we're combining not only safety issues and quality issues, but we're mixing in a little bit of artificial intelligence so that it can read deep down into the issues that we have, and it can identify what are the issues that we have. You know, let's say we have 400 or 500 issues on a job, right? How many of those were critical? Water related, infiltration on the envelope, roof related. You know, where you really eat up a lot of your budget on a project where you have a little bit of fade. If we knew the 400 issues that 5 of them were really important, like really impacting our bottom line important, then that saves me from having to try and figure that out on my own. So that's where this tool comes in really valuable to us. It's not on a project basis only, it's cross-project. So when we can look across our entire portfolio of active projects over the last about 7 years right now for us, and we can say of the projects we did, how many of them were office buildings and how many of them had water issues. And we can analyze very quickly what they were, and then we can go and talk to the project managers and find out why. Was it the sub? Was it management? Was it buyout? Was it timing? Was it weather? What was it? I mean, not to pick at anybody, we just want to know, like, what was the story. This gives us tea leaves to kind of start that process without having to pull out banker's boxes and dig through paper, which nobody likes to do. It also helps us mitigating risk. If we're going to end up in some scenario where we may have a little litigation or something pop up, we got to have our documentation front and center. So instead of digging through banker's boxes, we can run through a database really quickly and analyze that information and pull it up. Huge time saver. So I had a couple case studies here. Where are we on time? I'm going to kind of buzz through these really quickly because I think we've covered a lot of this. But I can always go back. You can always catch me later. All right. So this section I like to call "That's Neat, So What." So is anybody ever pitching technology in your company and the response you get is, okay, so what? Right? It costs money, right? It's going to take time to implement. It's going to take resources, right? So what? You can fly a drone. So what? You have this cool cloud-based platform. So what? Well, the way we approached it was, not just so what, but why would we change the way we've been doing things for, 30, 40 years? We knew we had data silos. We knew we had some legacy software for estimating. We knew that we were going to go through some attrition, right? We're having, this market, this industry is having a lot of attrition right now. People are retiring. They're coming in and out of the market. There's confusion as to how sophisticated this industry actually is and how complicated it actually is. And then as we're getting more and more people coming into the office and we're growing our company, there's other opportunities. We can leverage them and all the amazement that that is out there being marketed. But that allows us to do different types of quantification. It allows us to do it quicker or more effectively. It allows us to track the changes. Without reading all the things that are on here. At the end of the day, it allows us to have a better way to manage the process. At least that's the hope and dream, right? So for us, we kind of started with a couple easy things, so I have a little fun with you here. So if you can find Waldo, that's great, not the point of this slide. But so think about documents. You get a DD set of drawings, 25 or 50% set. A month or two later, you get 75% set of DDs. What changed? Right? If it was color like this, you have a fighting chance of knowing what changed. You know, if you just blindly walked in as an estimator, you know, you would have a fighting chance of finding it. But we don't get that. We get this. Right? It's all black and white. And we get it in piles. Piles and piles and piles of drawings. Right? There is no way that unless somebody gives you the secret decoder ring, you're going to figure out what changed on 400 sheets of drawings. Not going to happen. That's where the communication piece comes in. We've been doing this stuff for decades, right? This is not a new industry. But we have way more drawings than we've ever had. And I think the reference earlier was about 40 sheets for a project, and now it gets 250. We have projects that we normally have 200 sheets that have over 1,000 sheets. And it's just, the amount of information is overwhelming. So we sought out to find a different, better way to do this. So within our 360 suite, we had a way to compare drawings. But for the models, this becomes even more complex. You can figure out by putting things on a light table that two things aren't the same. You can do a little slide bar on a digital software and you can see what changes. But in a model, totally different realm, right? The awesome thing about them is that it's a big database. So if you know how to sort it and filter it, you understand the way that it was structured, the way that it was built, the intent of those things. Don't get me wrong, it's not all lollipops and unicorns, and we're going to talk about that. But if you understood the basics of how it was put together, you have a fighting chance now of really starting to dissect this thing. So this tool is an estimating platform that we've used for about 3 years now. And so it has this change, what's called a change management tool. Let's keep it simple. So the stoplight here that's green, red, and yellow is very quickly giving you the tea leaves on what has happened in the model from one iteration to the next. The stuff that's green is all new. The stuff that's red is stuff that was removed out of your model. And the stuff that's yellow is things that have been changed. Now, how do you change something in a model without adding it or removing it, right? So the example earlier that Mike used was around walls, right? So if you're an LOD 100, very conceptual level model, you may just model a three-dimensional element that represents a rectangle that looks like a wall, but it has no layers to it. It has no studs in it, it has no drywall layers, has no insulation in it. It's just dead geometry, right? But the one thing that it does have in a BIM is it has kind of like a serial number, a GUID. And once you keep that, or once you have that, it's established in your process. And that's your starting point, it's your baseline. Okay? So if you know that's your baseline, when you get the next set of drawings and somebody adds drywall to it, that same GUID updates. Now you know what changed. So the yellow changes a lot. But it helps you understand what's going on with the model. I'm not telling you to necessarily model right. At least you know what's going on with the model. You can ask questions or you can start to dissect it in a different way. This saves a ton of time. This is one of our favorite tools. I mean, we use the same thing with 2D, but with 3D, this is fantastic. As we go through the different estimates that we put out, now we can go back over our timeline and we can do a change tracker tool. And we can understand in version 1, version 2, version 3, version 15, what happened in all those estimates. Quick snapshots, or we can go back to the actual models, we can roll back in time, and we can see what's actually going on with the model. So the way that works is obviously we have to have an awful lot of inputs so we can get a lot of outputs. But to give you kind of a quick demo here, this should spool up. There it goes. So I mentioned earlier, so this is a product called Destiny Estimators from Back Technology. So what it's showing you here is it's able to load information from our main repository where we're hosting all of our coordination BIM, all of our architectural, structural, ADP models, all this stuff in one place. So as I'm the estimator though, now I can reach out into that repository and bring it into my estimating platform. I can bring in 2D and 3D stuff. This tool here is sorting and filtering that data. So if I know that the elements are best sorted and filtered using unit format, or CSI 16, or master format 48, or whatever, some of it's just custom properties. And we know that, hey, this was allocated to phase 2. And all we care about in this entire model are the phase 2 elements. It gives us a way to slice and dice this data without having to have the architect prep the model for us, or having the VDC team prep the model for us to make. This again comes back to the communication piece. Your strategy for how you're going to model and how your design partners are going to model plays a critical role in how quickly you can work through this process. Because I can tell you, models are not perfect. You're not going to get everything out of them right now. Maybe in a few years it'll get better. Today, models will give you a lot of the picture, but they will not give you everything. So, let's kind of dive into that a little bit. Where are we on time? 20 minutes. I'm going to leave some time for questions. So, spin through this really quick. So, not all models are created equal. Not all models are created consistent. Authors change. There's a handful of things that are thrown up here. There are definitely areas that you're going to struggle with 3D quantification. That's not to say you should avoid it. There's a lot of information you can get to here really quick that allows you to spend time digging into the details, or for to reach out to your submarket and get more input from the experts that are actually going to install and fabricate these things. But there are areas that you're going to struggle. If you're doing tilt-up projects or precast projects, the way that Revit quantifies things, the way that Navisworks quantifies things, and the way that these other tools do it is all just a little bit different, and you have to understand how that thing was modeled and how you're actually getting quantities back out of it. Curtain walls, a particularly fun area. If you're familiar with Revit, you can get the mullions and you can get the glass, but not the actual wall, right? Not the overarching wall. You can get it, you have to know how to do it. It's not very easy, and it's not right out there in front of your face. So there are different ways to get through this. I'm happy to follow up with somebody later if they want to know more about this piece. But in terms of how you're going to get the quantities out and how you're going to be able to compare them from one version to the next, this gets pretty tricky, and these are tough areas. Curtain wall especially. And there are some curtain wall manufacturers that quantify based on panels and aluminum, and they understand the weight and all those types of things. But in lay terms, we don't typically price like that. We typically price by square foot, right? So in that case, this becomes a particularly tough point for what we're doing. The other thing is with walls. So the way that an architect may model two walls and how they come together at a corner or at a T impacts the amount of quantity that you actually get. So up here in the top right, you'll be missing surface area where the two walls came together like this, and they weren't actually mitered together. So you'll be missing 9 square foot on a partition wall 400 times. And all of a sudden, you've got a gap. So this is where we have challenges. So these are the types of things that you have to look out for. And so it's not just about one person in your estimating department understanding this. This is where standards and training really become really important with technology. I can tell you that all the technology in the world is not going to help you roll this out to your organization and have them be efficient. It is always going to come back to communication and training. So, all right, so where else we got here? Kind of spinning through some of these last ones here kind of quick. All right, dare I ask what else is possible? So, kind of wrapping this up. So, talked a little bit about artificial intelligence earlier. AI and machine learning are kind of still in their infancy, even though they've been around for quite a while. Drones that we use today, the autonomous flight, is using a little bit of AI. It's using AI to stitch things together. It's using AI to plan the missions. And there's more coming. We have played with drones that can identify safety issues from 400 feet off the ground. They fly across the site, and they understand that that's a hard hat, and they look at the guy wearing the hard hat, and they realize he's not wearing safety glasses. So this is all in its infancy, but it's really going to start to come around. As an estimator, so what, right? So what we've started to dig in here over the last couple of years is what else can we do as pre-construction professionals to help look at a project in different ways? Architects are doing the same thing, but I'm in pre-con. I have an owner come up to me and say, hey, I want a hotel. I got a 5-acre site. I got some parking requirements. You know, what can we build for $10 million or $20 million? If I can load some basic rules into tools like Dynamo, Revit, well, using those two together, there's another product called Optioneer that you give it some basic rules. And I'm not trying to make this sound like it's super easy. This is not exactly like an easy button. But once you create it once, you can use it again and again and again. What this allows you to do is take a look at a project and say, what different types of configurations could I use on the job site? How many floors, how much glass area versus brick area, all those types of things. And I can start to analyze really quickly, what is the right solution for this particular owner, this site, this budget, what have you. If we can get this to kind of this is close. It's not what it's going to look like. I definitely don't want my building to look like that. But it's going to be L-shaped and it's going to be 3 stories high. It's going to fit on the site loosely like this. Now I can hand that off to my design team as the owner and say, this is not what I want it to look like. This looks like a box. I don't want a brick box for a building. But this is the program that's going to work for my budget, to my knowledge. Now we've got a starting point, and the design team can take off from there. Not just the architects, the MEPs. For us, we want to know, is it going to function well? You know, how big of a rooftop unit are we going to need? What's the floor-to-floor height really going to be? If I can reduce my floor-to-floor height, I can take away some skin. So all these different variables allow me to study that in a different way. Now, this gets more complicated as it goes, because you have to have an intimate knowledge of how to use products like Dynamo and Optioneer to really develop these different alternatives. But this is what's possible. Same thing, this is a really cool tool. It's for building systems planning. I think they released this about 2 years ago now. But we get into bid coordination processes in existing facilities, trying to figure out how to route ductwork and piping. This uses AI to figure out where it can route things on its own. Imagine you create the envelope of the building that you want, and at some point in 3 years or 5 years, it can actually route all the systems for you. This is exactly what this is doing 2 years ago. This is 2 years, almost 3 years ago, I think. This is 3 years ago. And is anybody, I get super excited when I see this video and it's 2 or 3 years old now. I mean, this is going to impact how we design buildings, how we cost buildings. If we can automate more and more of this, we could actually create a basic set of rules of what we wanted, and in theory, it could design and price itself. We're not there yet, but in theory. All right, so let's move forward here. So again, we get back to data. So what's in it for you, right? So kind of break it into 3 basic buckets. You have the pre-construction bucket, the construction budget, and the facility management bucket. Right? We spend an awful lot of energy designing buildings and building them, and we have this 50-year, 50-year time cycle afterwards that we're not too concerned about, but we have an awful lot of data that could impact that. So if we're in the virtual phase, we can do better takeoff, we can do it more often or better, hopefully. We can visualize it better, we can get through that coordination process faster, we can do the buyout faster. We can make sure we have confirmation on what the design is and that it's actually what our clients want. When we get into construction, we can leverage that same model, that same plan, and track it because we've created the baseline for the rest of the construction cycle. That only comes with some confidence from the project team, so now they're using robotic layout because they're prefabbing and they want these things to fit. They don't want to have a waste factor, right? Their goal is 0 waste factor, right? No more 1%, 10%, 15%. My mechanical contractor wants 0 waste. That's the goal. Well, if I can get to close to 0 waste, that's doing something. So we get through the construction cycle, now we have a fully coordinated model with all the documents, the entire history of how it was built and how it was commissioned, and now I can hand it off to someone who's going to actually operate that facility. If I'm a semi-sophisticated owner, I have an awesome database to start with. And I don't have to go and laser scan it, I don't have to go and run drones over it, I don't have to go and have somebody else model it. I just start with the database that is already created for me. And I just got to take off from there. So it comes down to better communication, so we can make more informed decisions. And that ultimately results in speed to market. And hopefully, we are getting to a target value design that is meeting the quality and expectations that our clients are demanding in a way that we can actually supply it and be confident that we are mitigating all our risk as builders. So with that, I know it was a lot, we jammed through it. If you got questions, any questions? Or do we just need more coffee? Not a single question? All right. All right, thank you guys. Appreciate it.